Alright, Miss Teasley here. Today we're going to talk about linear functions and their graphs. So in the box they have information about a linear function. The way that you know that you're dealing with a linear function is because you're going to have the variable x. Kind of highlight the x. So x, not x squared, not x to the third, but only x. So if you only see x, then that's in linear form. Or if it didn't have an x, but we'll get into that. So basically a and b are numbers and x is your variable. One thing that's important to remember about the domain of a linear function, if a does not equal 0, all right, so this only applies if like there's an x there. If a does not equal 0, the domain and range of a linear function are both all real numbers, from negative infinity to positive infinity. So we're going to start doing some graphs. And they asked us to graph this linear function. All right, 3 over 2x plus 6. Give the domain and range. We're going to be graphing this linear function using intercepts. All right, so we talked about intercepts before. Intercepts is where the graph crosses the x and y axis. So to find the x-intercept, all right, so algebraically, to find the x-intercept, this is the point where the graph crosses the x-axis. So if you notice, all the points on the x-axis, they have an x value, but the y value is 0. So your x-intercepts will look like that. So to find the x-intercept, you let y equal 0. So substitute y equals 0, and then solve for x. All right, so let's go back to the original function. F of x is just another way of saying y equals. So y equals 3 over 2x plus 6. To find my x-intercept, in place of y, so in place of y, I'm going to replace y with 0. So substitute 0 in for y. So I'm going to make this a 0 equals 3 over 2x plus 6. And this is the equation that I'm going to solve for x. So to solve this, you want to subtract 6 from both sides first. So that's negative 6 equals 3 over 2x. To get x by itself, I'm going to multiply both sides by 2 first of all to get rid of the 2 in the bottom. So times 2. So they cancel out. So this is negative 12 equals 3x. And then to get the x by itself, I'm going to divide both sides by 3. So x equals negative 4. This is your x-intercept. I believe in my math lab, they just want you to type their number in. But as an ordered pair, as a point, this is the point negative 4, 0. So on my graph, I'm going to plot the point negative 4, 0. So this is where my linear function is going to cross the x-axis. All right, when you see the word linear, all right, the word that pops out is line. So that's the way I remember that a linear function represents a line. So this is going to be a line at the end. To find the y-intercept, y-intercepts, when you write them as an ordered pair, is going to be 0, comma, a y value. So algebraically, to find the y-intercept, we let x equal 0. All right, so let x equal 0, and then solve for y. Let me see if I can leave some space. Oh shit. All right. All right. Solve for. All right. Sorry about that. All right. Then solve for y. So going back to the original function, f of x represents y. So this is y equals 3 over 2x plus 6. To get my y-intercept, in place of x, I'm going to put a 0. So this is y equals 3 over 2. And in place of x, 0 goes here, plus 6. So this x became a 0. Anything times 0 is 0. So this becomes 0 plus 6, which is just y equals 6. So this is your y-intercept. As an ordered pair, it would be 0, 6. So when I plot this point on the graph, this is 0, 6. And that's all you need to sketch a graph of a line. All you need is 2 points, and then there's your line. So in MyMathLab, you'll plot those 2 points, choose the line feature, and it will graph it for you. So that's how you find x and y intercept. The domain and range for the domain for this graph and range would be all real numbers. So domain and the range. These are both negative infinity to infinity, negative infinity to infinity. All right, moving to example 2, graphing a horizontal line. So this says f of x equals 2, which means y equals 2. So that means regardless of what my x value is, y is always going to be 2. So I'm going to make a little table. So I'm going to plot 3 points. So I'm going to say y is going to be 2 regardless of what it is. So I'm just randomly choosing 3 points so I can show you how this graph is going to turn out. So y equals 2 means that the graph is going to be y equals 2 regardless of what x is. So let's choose x equals -1, 0, and 1. So those are 3 points that I can graph. So at -1, 2, that's a point, 0, 2, and even 1, 2. So if you notice, all 3 of those points line up and they form a horizontal line. So this is the equation that represents this graph. This is a horizontal line. The domain for this graph, it stretches wide from negative infinity to infinity. The range, there's only one y value, and that y value is 2. So the range, since your range is just one single number, you write it like this in the little braces. So the range is just 2. Graphing a vertical line. To graph x equals 5, this says that x equals 5 regardless of what y equals. So let's do another table. So I'm going to put 5 down for 3 x values, and let's just choose 3 different y values. I like to use a negative and positive number, so I normally just do -1, 0, and 1. So let's plot these points. So I have a point at 5, -1, a point at 5, 0, and a point at 5, 1. So if you notice, these lines line up and they form a vertical line. All right, the domain of this is just one single value of 5, so 5. The range would be all real numbers. All right, it's tall, it goes from negative infinity to positive infinity. This is not a function. We talked about that because it fails the vertical line test. All right, function means that you can't have a vertical line hit more than one point, and this line is a vertical line, so every single point has the same x value, so this is not a function. All right, but that's it. So that's how you graph a vertical and a horizontal line. This will be one that I want you to pause the video and try. I changed the equation. The original equation is 3x plus 4y equals 0. change that to a 12. You're going to graph this by finding the intercepts, x and y intercept. So that means you'll have to plug in 0 for both and solve. So pause the video and try. All right. So now to graph this equation, I'm going to first start off by finding my x-intercept. So remember, to find an x-intercept, you let y equal 0. So using this equation, which is 3x plus 4, in place of y, I'm going to put a 0. So that equals 12. So basically that 4 times 0 drops off, and I just get 3x equals 12. To finish this off, I'm going to divide both sides by 3. So x equals 4. This is the x-intercept. So that means the graph crosses the x-axis at 4. If you write it as an ordered pair, it's 4, 0. So 4, 0 is that point. To find the y-intercept, we're going to let x equal 0. Okay, so y-intercept, we're going to let x equal 0. So taking the same equation, I have a 3, but I'm not going to write x. In place of x, I'm going to put 0. Plus 4y equals 12. 3 times 0 is 0, so I'm left with 4y equals 12. Divide both sides by 4. You get y equals 3. That's your y-intercept. As an ordered pair, that would be 0, 3. So on the y-axis, I'm putting a point at 3. And so those two lines together make up my graph of my line using intercepts. The domain and range of this line, they're both going to be all real numbers. So domain negative infinity to infinity, and the range is also negative infinity to infinity. Alrighty. Now I want to talk about slope of a line. All right, the slope of a line measures the steepness of a line. Well, the slope is the steepness of the line. All right, so pretty much how steep is the line. I want to go over an example of the different types of slopes. So when we start graphing, you'll hear me say slope. All right, so first of all, the variable for slope, so they have it here. Slope, we use the variable m to represent slope. So anytime you see m, they're referring to slope. Slope is the rise or run. So your steepness of your graph. That triangle means delta x, or changing y values over changing x values. We'll use this formula to help us find slopes when we're given 2 points. It's good to know what all the different slopes look like, what all the different graphs, what the different slopes look like. So anytime you see a graph that's increasing, so from left to right, you're increasing, this is going to have a positive slope. Any graph that's decreasing from left to right, so I'm just putting an arrow decreasing, this is going to have a negative slope. A horizontal line, there's no rise or run, right? So this is a horizontal line. This is going to have a 0 slope. And that's how I remember that it's 0, because if you look at the letter Z, it's made up of 2 horizontal lines. So this is a 0 slope. And then a vertical line slope. Oops. Try not to. This is a vertical line. A vertical line slope is undefined. And so if you take the U and you extend it, that's the way I remember undefined slope. So where it says the slope of a vertical line, it's undefined. And again, I showed you how I remember by the U being made up of a vertical line, and then for zero slope, it's made up, the letter Z is made up of horizontal lines. So that's the way I remember. All right, so let's talk about how to find slope using the slope formula. So the slope formula, M equals is y2 minus y1 over x2 minus x1. Those are little subscripts, and we'll talk about what they mean. So you're going to be given 2 points. Each point or ordered pairs is a x value and a y value. So to distinguish between the 2 points, they put a little 1 to represent this is the first point, and they put a little 2 to represent this is the second point. So that's how you label your points. So find the slopes with the slope formula. So again, M equals, I will go ahead and label it. This is x1, y1, x2, y2. And you're just plugging it right into the formula. Y2 is -6. The formula has a minus sign in it, so minus. Y1 is 4. All over x2 is 2. Minus, because there's a minus in the formula. And x1 is -2, so minus a negative. So it's important that you know that the minus sign that's in the formula is separate from the sign of the number. So like at the bottom, this -2 has nothing to do with that minus in the middle. So you need to make sure you don't forget to do that. So when I simplify this, I get -10 over, when you have two negative signs, a minus, a negative, that becomes a plus. 2 plus 2 is 4. And if you simplify that, you get -5 over 2. So this is the slope of the graph or the line. So without me even actually knowing any points or how to graph, the actual equation of the graph, I'll say, I already know that when I graph this, it's going to be a line that's going to be decreasing from left to right. So it's going to be a negative slope. So the B and C, we're gonna use the same formula. These are special types. This is where I want you to stop and pause and maybe try these 2 examples I'm kind of highlighting. You got an 8 here, both of those repeat, and then they both have a -4. So just try using the slope formula, see what happens, see what you get. All right, so pause the video and then we'll come back. All right. So using my slope formula again, let's use pink. So this is my x1, y1, x2, y2. So M equals 8 minus 8 over 5 minus a -3. So I get 0 over 5 minus a -3 becomes a 5 plus 3, which is 8. 0 divided by anything is 0. So this slope has a 0 slope. So since it has a 0 slope, remember 0, horizontal line. All right, that's how the graph of that line will look. Then here, M equals, using the slope formula, 10 minus a -10 over -4 minus a -4. So here, when you do that, you have double negatives, so this becomes a plus 10 plus 10, which is 20. And then this becomes a plus, so -4 plus 4 is 0. Oh, well, I have a 0 in my denominator. When you have a 0 in your denominator, this is what I say is undefined. I use the word underfined to help me. Hope I can move this out of the way. Okay. Underfined. That's how I remember that a fraction that has a 0 in the denominator is undefined. So this is really undefined. because the 0 is under the fraction bar. So since it's undefined, remember the letter U is a vertical line. So this is going to be a vertical line. So those 2 points are points that lie on a vertical line. All right, slope equal to 0. The slope of a horizontal line is 0. All right, slope is the same no matter which pair of distinct points on the line are used to find it. So meaning that I can choose any 2 points I want to on a line. When I calculate the slope, it'll be the same. All right, to find the slope using an equation, you have to solve for y. So this is called y equals mx plus b form. All right, this is slope intercept form. So y equals mx plus b. This is called slope intercept form. M is going to be the slope. So whatever number you have in front of x, that's going to represent your slope. So I need to solve this equation for y. So solve for y. So this is 2x minus 5y equals 10. So my goal is to get y by itself. So I'm going to get rid of the 2x by subtracting 2x from both sides. So I have negative 5y. The 10 and the 2x, they're not like terms, so I need to just put them beside each other. You'll want to put the x part first. So this is negative 2x. And the 10 is positive, so you put plus for positive 10. And now to get y by itself, I need to divide everything by negative 5. So y equals negative 2 over negative 5. 2 negatives makes a positive, so this is 2 over 5x. A positive 10 divided by negative 5 is negative 2. So this is the form y equals mx plus b. The slope, to answer this question, the slope is 2 over 5. All right, that's your slope. Because it's positive, I know that this is going to be a line that's going to rise or increase from left to right. Let me rewrite this. So you want to write your fractions like this, 2 over 5. Alrighty. Now we're going to graph using a point and a slope. So earlier when we talked about slope is also the rise over the run. So the rise means the up and down. How far up and down you go. Oops. So up, down movement. And the run is your left, right movement. So since this slope is positive 4 over 3, that means I'm going to go 4 units up and 3 units right, because positive is on the right side. Positive 4, when it comes to up, down, is going to go up. You can also write this as a negative 4 over negative 3, because 2 negatives makes a positive, so these are the same. If I write it in that form, that means I can go 4 units down and then 3 units left. And we're actually going to do both, so you'll see that they both work. All right, you only need 2 points to graph a line, but I'm going to show you both. So it says graph the line passing through the point negative 2, 3, having a slope of 4 over 3. So you want to start off with this point, negative 2, negative 3. So negative 2, negative 3 lies here. The slope is 4 over 3. So starting from this point that I plot here, negative 2, 3, I'm going to go up 4. I'm going to count up 4. 1, 2, 3, 4. And I'm going to go over 3 to the right. 1, 2, 3. And that's going to give me my next point. So it looks like this. You can also start back at that same point. And this time I'm going to do it using the -4 over -3. So I'm going to start from here and I'm going to count down 4. So 1, 2, 3, 4. And then 3 to the left. 1, 2, 3. And there's another point on that line. So if you notice, they all line up. That's how you use slope. So if you were to do this in my math lab, you will only have to graph the point that they give you in either the blue point or the purple point. Any one of those is fine. You just need 2 points. But that's how you would use the slope to plot the points. Rise or run. A line with a positive slope rises from left to right. A line with a negative slope falls from left to right. A line with blank blank neither rises nor falls, so this is 0 slope. And the slope of a blank blank is undefined. Of a horizontal, sorry, not horizontal, but a vertical line. Is undefined, so this would be your vertical line, and this is the one with the 0 slope. All right. So I'm gonna stop there. That should cover 2.3. All right, and I'll go to 2.4.